Now let's talk about this SAS triangle area formula. So if you were given a triangle here and you were to ask to find the area, back from grade school you would use 1/2 base times height. Now the only thing with that can be an issue is if you choose as your base, let's say it would be the 10.6, you would need the height. The height is a perpendicular height, so you would have to actually drop a perpendicular here, and you'd have to compute that height using SOHCAHTOA, and then you could use this. Well, I don't want to have to do that because this is not a right triangle. I want a quicker method, and let me show you this new method you can use. If you look at it, it's really similar to 1/2 base times height, but it's actually 1/2 AB and then the sine of the angle C. So what that means is you pick any two sides, it doesn't matter which two sides you pick, and then you pick the angle of the side you didn't choose. So for example, if I look at this particular triangle here, I can actually write 3 completely different area formulas and get the exact same answer each time. I could first choose, if I wanted to use these two side lengths as my A and my B. This would then be side length C, so really I'm talking about using this angle. So the trick really is pick two sides and then the angle that those two sides include. So I could write one area formula as I would do 1/2, I would do 5.7 here times 7.9, and then I would do the sine of 101. So I could do that version of it if I wanted to. However, I could also have chosen to use this side and then the angle that that one makes. So I could have written 1/2, this time again 5.7, but I'm going to use the 10.6, and then I'm going to do the sine of 47 degrees. Now the other option I would have had is I could come on in and I could have used the 7.9, the 10.6, and the angle that one makes. So I could have done 1/2, 7.9, 10.6, and then here the sine of 32. So if I crunch any one of these 3 out on my calculator, I'm going to get approximately 22.1, and this would have been squared miles. Now, I wouldn't do all 3 of these versions. You would just pick one of the 3 and you could do it that way. So here's actually a nice visual example of using the old triangle formula in this new one. Again, this old formula only works for a right triangle. Well, here is a right triangle with a base of 5 and height of 8, so I could do 1/2 base times height and get 20. Or I actually could use this standard formula here. If I choose for my A and my B as my side lengths, what if I chose 5 and 8? Then I would use this angle here, which is 90 degrees. From chapter 4, you could recall that the sine of 90 degrees on our unit circle is 1. That actually becomes 1. So really this formula here is the same as that formula. I like this new one because it works for any triangle. Now the last thing I want to highlight is when should you use which method. You really can try whatever you want, but my kind of recommendation is first, if they give you a right triangle, I personally would probably just go ahead and try SOHCAHTOA or Pythagorean's theorem, either one of those. If it's not a right triangle, then my next suggestion is, just because of the easeability, I personally would try law of sines. I like that law of sines as a quick method. When you do like law of sines though, before you start trying to figure out how to set up the formula, if there's any angles you can fill in, because if they give you 2 angles on a triangle, could you find that third one? I like to fill in all that missing information. It just kind of gives me more to work with. Now if you realize that law of sines doesn't work, then obviously you're going to be left with wanting to go and having to try law of cosines. And hopefully one of those 3 methods should work. On your final assessment, I don't care which method you use as long as it's proper. Sometimes you could almost use all 3 of them if you really wanted to, and you can just set it up and solve as needed.